Alright, welcome to our next section on 12.3 odds. Now odds are always given as odds against unless it's stated otherwise. So if you're looking at a betting odds, you always see the chances against winning to the chances of winning, and so they're listed as odds against. So odds against an event is the ratio of the probability the event fails to occur to the probability the event will occur. So what we do is basically we take the ratio of the event not happening and compare it to the probability of the event happening. Now if we talk about odds in favor of an event, this is just going to be the reciprocal of odds against. So basically it just switches places and we list in favor first and then odds against second. So the way we do this is we have the odds against an event is the probability of failure to the probability of success. Now the way we can find this is actually to find the number of failures and put it with the number of successes. So how many times does the event fail to occur compared to the number of times the event actually occurs? So it's failure to success. Odds in favor of an event is just the reciprocal. So the success and the failure switch places, and so it's the probability of success to the probability of failure. So for odds in favor, we have the number of successes to the number of failures. Okay, so you just have to list how many times is the event successful compared to how many times the event is unsuccessful, and this gives you your odds in favor. Now when we describe a probability, we use the word in. So this probability is said 1 in 5. Okay, so we say 1 in 5. It means 1 in every 5 chances has had a successful event. When describing odds, we use the word 2. So we say 1 to 4. So basically, if this were odds against, we would say, well, it didn't happen 1 time to it happening 4 times. Okay, so probability and odds tell us the same information, but just in a slightly different way. Let's do some problems now. One of the major things we have to think about with odds is how can we change odds against into odds in favor and into probability. So you need to be very adept at going from any one of these to the others. So in order to do this, we have to think that odds against are the number of failures to the number of successes. The odds in favor are the number of successes to the number of failures. And then for probability, it's going to be the number of successes divided by the total number of trials, which would be success plus failure. So looking at these three things, if I know the odds against are 4 to 1, to find odds in favor, I just switch that around and I say 1 to 4. Now if I want to find the probability, I need the number of successes, which is 1, and then I need to divide that by the sum of the successes plus the failures, which would be 1 plus 4 or 5. So 1 in 5 probability is the same as 1 to 4 odds in favor and 4 to 1 odds against. So now if I'm given odds in favor, now I know I have 2 successes and 3 failures. So odds against would be 3 to 2, because that switches around. And then the probability, well, there were 2 successes over 2 plus 3 for 2 successes and 3 failures. So that would be 2 in 5. Now in this case, I'm given the probability of 4 over 9. So I have to think of 4 over 9 equals my successes over my successes plus my failures. So when we look at this, I see I have 4 successes, and so we can replace that S with the 4. So how many failures do I have? Well, if there are 4 successes out of 9 trials, that means 5 times I would fail. So you just go 9 equals 4 plus our failures, subtract 4. So this is how you think about this algebraically. You can also think 4 plus what equals 9, and the answer is 5. So now that I know I have 4 successes and 5 failures, we can write our odds in favor as 4 to 5, and then the odds against would be 5 to 4. Alright, if you can do this very fluidly, then when we get to word problems, like our next set, it won't be too bad. Alright, so let's take a look at some word problems here involving our odds and probabilities. So it says, find the odds against rolling a 3 on one roll of a normal 6-sided die. So what I like to do is I underline what we're given. So we're given odds against, and then I box my event. Okay, and a couple things we need to find here is the number of the event. So in this case we want the number of 3's, and there is 1 3. And then we also want the number of not the event, and in this case there are 5 that are not 3's. So if we want the odds against, another way we can think about it, it's the number of not the event to the number of the event. So if we're looking for odds against, this would just be 5 to 1. So the odds against rolling a 3 is 5 to 1. Now in number 2 it says 7 out of every 9 people who apply to Stanford get rejected. So if you were to apply, what would the odds against being rejected be? Okay, so looking at this, we're trying to find odds against. The event is being rejected, and in this case they give you a probability. It says 7 out of 9. So I like to circle my probabilities. So we need to figure out the number of the event, which in this case is being rejected. So I'm just going to change that to the number of rejected, and we also need the number of not rejected. So how many people were rejected? Well, 7 out of 9. So 7 people were rejected, which leaves how many people not rejected? Well, if there were a total of 9 people, there would have to be 2 people that were not rejected. Now if we're looking for odds against, we want the number of not rejected to the number of rejected. So in this case, this would be 2 to 7. Alright, in number 3, 2% of the United States population is born gifted. 2% is a probability. And being gifted means you have an IQ greater than 130. It says find the odds in favor, so I'm going to underline that, of being born gifted. So this is my event right there. So let's find the number of people being born gifted and the number of people who are not born gifted. Okay, so if we have a probability here, this means 2%, which is 2 out of 100, and we can reduce that to be 1 out of 50. So when we look at this, it actually gives us the number of gifted divided by gifted plus not gifted. So when we look at this, there's 1 gifted person, and then the rest are not gifted, meaning there are 49 that are not gifted. Now odds in favor, that's going to switch around. So odds in favor is the number of the event to the number of not the event. So here the event is being gifted and there is 1. and then not being gifted is 49. So the odds in favor of being born gifted is 1 to 49. All right, in number 4, 23 out of 27 students pass the chapter. So here's our probability with the event of passing. So find the odds in favor of not passing the test. So we want odds in favor of not passing. Okay, so this one's a little bit tricky. Let's go ahead and find the number of people passing and the number of people not passing. So if 23 out of 27 pass, that means the number of passing has to be 23, and making the number of not passing 4, because 23 plus 4 adds up to be our 27. Now we want odds in favor of not passing, which means we technically want not passing to passing, because we're in favor of not passing. So this has to be 4 to 23. All right, number 5. If the odds against winning are 9 to 2, find the probability of winning the game. So we want the probability of winning. So what we need to do is find the number of winning and the number of not winning. So if we're given odds against winning, this actually already is in not winning to winning. So that means there were 2 winning and there were 9 not winning. So we want the probability of winning. So we think we need the number of winning over the sum of winning plus not winning. Okay, so there were 2 winners out of a total of 2 plus 9, or 11 total tries. So the probability is 2 in 11. For number 6, it says the odds in favor of winning are 3 to 7. Find the probability of losing the race. Here we want to find the number of winning and the number of not winning, which we also can think of as losing. Okay, so if the odds in favor of winning means we have 3 wins to 7 not wins. So the number of winning is 3, the number of not winning is 7. Now what we're looking for is the probability of losing the race, and we can think of that as the probability of not winning. So we want the number of not winning over our total. In this case, 7 don't win out of a total of 3 plus 7, or 10. So the probability of losing is 7 in 10. All right, so that is one way that we can figure out all these problems, dealing with odds against, odds in favor, and probability.